One of the more interesting things about AC power and AC circuits is the idea of the three-phase electricity. And actually what happens at power plants is they don't produce just one wire coming out of there that has an AC circuit of 120 volt RMS with a 60 hertz cycle if we're in the US. But what actually it does is it produces three different wires that have this circuit. There's actually four wires coming out of a power plant, and one of them is just the common ground. But what we mean by three different phases is that instead of having one wire that starts at some value, peaks, goes from peak to peak to peak, we actually are going to take the other two wires and have them produced in a similar manner. But we're going to delay one to the next to the next. So the cycle, we start one cycle when we're a third of the way through the first, and we start the last cycle when we're 2/3 of the way. So we start one at 0, we start one at a third, one at 2/3, and then we repeat ourselves when we get to 3/3, 4/3. So mathematically, or in a graphical way, we start, move up, move down, move up, down. We delay the second one by a little bit, so it peaks just a little bit after the first, and then similar for the third, we peak a little bit after the second, which then happens to repeat itself. We get the first, second, third, fourth, first, second, third, and we keep this pattern. And it delivers us a little bit more uniform power if we use all the phases. And it's kind of interesting to see how actually power plants work in this. They use this thing called the step-up transformer. Really, they induce a current, or they use this AC current to induce a magnetic field. That magnetic field induces a separate current. And depending on the coils, we can switch out voltage for current and current for voltage. So what we're going to do is we're going to increase the voltage in this step-up transformer. We step the voltage up at the cost of current, and the current will be decreased. So we'll have high voltage lines with lower current. And this actually allows us to efficiently deliver the power over a larger distance. And the reason for this is that there is some internal resistance in wires, and that internal resistance, if we have the high current, will cost us a lot of power. So we put up the voltage, decrease the current, and we can actually make this more efficient. Then at the other end, we go backwards. We use a step-down transformer, which converts the voltage from the very high voltage levels down to the 120 volt RMS that we're used to seeing in our houses or offices. And the three phases actually has an interesting concept with it, is that most of the stuff we use in our house, we only get one of the three lines that goes to our house. However, there's many places, such as UT, that actually get all three phases to come into campus. And these three phases we can use in some electricity, or use some for some electrical appliances. Your dryers, actually, some dryers work off of multiple phases, and some heavy equipment, such as milling machines or metal lathes, will work off of three-phase power. And this actually is kind of nice because it allows them to utilize this phase shift that we saw in the three different lines to more efficiently and more smoothly run their motors or whatever they're trying to use. It gives us a little bit more uniform delivery of our power without actually having to go to DC power.